Hello students, welcome back to my channel. I'm here again with a new video. This time it is on computational complexity. Though computational complexity also comes in section C of ISC question paper, but it has some importance of it in programming field. So let us proceed without a delay. First of all, there is an important question. How efficient is an algorithm or a piece of code? Now, there's a lot of theory in that, but overall, the efficiency covers few points like CPU uses time or CPU time usage, memory usage, disk usage, and network usage. So what is an algorithm called complexity? An algorithm is a procedure for accomplishing some tasks which, given an initial state, will terminate in a defined end state. Now, different algorithms may complete the same task with a different set of instructions in less or more time, space, or effort than others. To compare the efficiency of algorithm, the most common way of qualifying an algorithm is asymptotic notation called big O notation. Big O notation is a formal method of expressing the upper bound of an algorithm's running time. It is a measure of the longest amount of time it could possibly take for the algorithm to complete. The complexity of a program or algorithm is caused by taking into consideration how long the program will take to execute, the amount of resources it will take up, and how easy the code is to read and understand by others. Therefore, we can say that program complexity is the measurement of an algorithm with respect to time and space. The performance of an program is measured in milliseconds, that is its speed of execution, but complexity is measured in form of big O notation. For example, if we say big O1, it means the order 1 and describes programs where statements are simply executed one after another. These programs or methods are described as constant time methods. So we can say big O notation is the unit of measurement of an algorithm. Let us see few concepts of analyzing the algorithm. First of all, constant time or big O1. This means that algorithm requires the same fixed number of steps regardless of the size of the task. For example, printing the name of a student, push operation or pop operation in a stack or a queue, where one operation will be executed and it will take one constant time. Next one is linear time complexity, which is big O n. It means the algorithm requires a number of steps proportional to the size of the task. For example, finding the factorial of a number, finding the minimum element in an unsorted list of n element, calculating nth factorial or finding nth Fibonacci number, and so on. Next is quadratic time complexity or big O n square. Here the number of operations is proportional to the size of the task squared. Or we can see in other words, it's a nested loop. For example, simplistic sorting algorithm made with selection sort or insertion sort or bubble sort, comparing equality of two-dimensional array size n cross n, finding duplicates in an unsorted list of n elements, etc. Logarithmic time complexity. Here, the algorithm is proceeded like for n, first for n elements, it will, in the next process, it will be n by 2, then n by 4, n by 8, and so on. So here an example, binary search, where the array search element is found at mid element and then it divides the array in two halves and proceeds further. Or insert and find operation of a binary search tree with n nodes. Next is n log n time complexity. Here we have quick sort, merge sort, etc. Then exponential time complexity. Here we have like recursive Fibonacci or Tower of Hanoi, etc. Now, if we consider the order of asymptotic behavior of the function, here we have in ascending order, big O 1, then big O log n, big O n, big O n log n, big O n square, big O n cube, followed by big O 2 to the power n. So we can say here from this list, big O 1 has the lowest complexity, whereas big O 2 to the power n has the highest complexity. Now let's see some examples. What is the worst case complexity of each of the following code fragments? We'll consider few cases. First one is given if-else structure. So you can see here we have if condition, if we denote it as C1, with if there is a sequence of statement denoted by S1. After if with the else, there is another set of statement denoted as S2. Now if you consider this, C1 will run one time, S1 will also run one time, or S2 will run one time. So total time taken will be C1 plus S1 or S2, or we can say C1 plus S1 or C1 plus S2. So here we have the complexity as big O 1 plus 1. It will be big O 1. This is because in complexity calculation, we have only 1 as a constant factor. No other number is being taken into consideration. Let's proceed further. Here we have to keep in mind one thing. Though if-else structure gives you complexity 1, but if the if structure has n number of conditions, where each condition one by one will be evaluated until it finds the true condition, in that case, the time complexity will be big O n, not big O 1. Let's move further with a single loop. So here we have a loop running n times with a statement denoted as S1. So total time taken will be S1 dot n. So complexity will be marked as big O n. Next, we have two loops in row. One is n times the statement S1 is running, and then statement S2 is running m times. So the total time taken here is S1 dot n plus S2 dot m. So we'll say the complexity will be big O n plus m. Now, if we consider both loop runs n times, so then the complexity will be big O n plus n equals to big O n, because we don't have any other value. We cannot have big O 2n. It will be big O n only. In a nested loop, let us see what happens. So we have one nested loop where statement S1 is running, followed by a single loop that runs S2. So S1 will run n1 n minus 1 time into n1 minus 1 time, whereas S2 will run n times here. So the total time taken is S1 dot n minus 1 dot n minus 1 plus S2 dot n. Sorry, it will be n. So complexity will be big O n dot n plus big O n, where big O n dot n will be considered as the dominant term. So the complexity will be big O n square, leaving big O n. Now here one question may ask, what is dominant term? I have shown you that list of big O 1, then big O n, big O log n, big O n, big O n log n, n square, n cube 2 to the power n. In that order, whichever has the highest complexity, that will be the dominant term with respect to the others. And thus the dominant term will supersede all other subparts or the complexities, and thus that will be the final complexity. When do constant matter? Recall that when we use big O notation, we drop the constants and the lower order terms. This is because when the problem size gets sufficiently large, those terms don't matter. However, this means that two algorithms can have same big O complexity, even though one is always faster than the other. For example, suppose we have algorithm 1 requires n square time, and algorithm 2 requires 10 into n square plus n time. Now both algorithm have the time complexity big O n square, but algorithm 1 will be faster than algorithm 2. So in that case, we can say the constant and the low order term do matters, of which algorithm is actually faster. Let's see some more thing. One question comes here. There are three cases: best case, worst case, average case in case of finding algorithm, complexity of an algorithm. Now the best case is, as we will say, which has the lowest complexity. So in that order, we can say always big O1 will be the best case for any algorithm if it is. Worst case is how the algorithm runs on the worst possible inputs. So here it is taken for same example of search, linear search for n elements. Best case is big O1. Worst case will be big O n. Now what is average case? Average case is how it runs on most inputs. For example, to sort 10 lakhs numbers, the quick sort takes 20 lakhs steps of average, while bubble sort will take more than that, enough. So we can consider which will be the average case. Now here are some examples given. That is array sorting algorithm. From this table, you can see best case, average case, worst case of time complexity, and space complexity remains only the same, worst case. Now, case complexity we have already discussed. Polynomial time algorithm, that is big O1, big O n, big O n squared. Sublinear time, big O log n. Super polynomial time, big O n factorial, and big O 2 to the power n. Now, below they are given a link. This will also be provided in the YouTube. You can go through this link. There I have put some important short questions that might come in ISC from this chapter. Those will be helpful for you as they are direct questions from this chapter, complexity calculation. So this much from my end in this video. Thank you and all the best for you. Thanks a lot.